Okay, let's dive right into this. Every single day, millions of us casually open our laptops or grab our phones and type a question into ChatGPT, right? Or maybe we generate one of those stunning AI images in literally a few seconds. We see the result instantly, basically like magic. But, we rarely stop to think about the massive, totally invisible infrastructure that's actually powering all that magic. So this explainer is going to take you right behind the curtain to reveal a seriously fascinating reality. So ask yourself, where does AI actually live? I want you to really try and picture the physical location of the thousands upon thousands of incredibly powerful computers working day and night to generate those AI responses. They don't just exist floating around in some virtual cloud, right? They exist in massive, highly physical buildings. But where exactly are they?
Well, the answer might actually surprise you. Beneath a frozen island covered in volcanoes. Seriously, this isn't science fiction. This is Iceland. Right now, Iceland is quietly becoming one of the absolutely most critical places in the global AI race. The world's biggest tech companies are currently pouring billions of dollars into this tiny country, a place with fewer people than a lot of mid-sized cities, honestly. And it's all because of what lies right beneath their feet.
Which brings us to Section 1, the AI compute crisis.
See, the crucial point is we're currently facing a massive bottleneck because artificial intelligence is growing at a rate that is frankly way faster than anyone expected. And that explosive growth, it comes with an enormous physical cost. Let's break down this mismatch. Every single new AI model needs thousands of highly powerful GPUs running continuously. We're talking about running them non-stop, 24/7 for weeks, sometimes even months, just to train one single model. Traditional tech hubs are really struggling with this. Why? Because their power grids depend so heavily on fossil fuels. They simply can't keep up with this explosive demand without totally maxing out their grids and causing massive carbon emissions.
And that brings us to the core of the problem. If we define an AI data center, it's essentially a facility requiring massive amounts of continuous electricity to power thousands of GPUs for AI models. These data centers consume just staggering amounts of power. Because of this, tech giants are desperately searching the globe for locations that can offer unlimited, reliable, and most importantly, clean energy to keep their operations running without, destroying the planet in the process.
Let's look at Section 2, unlimited geothermal power.
That desperate search for power is exactly why Iceland steps up as the perfect solution to this massive energy crisis. The geography here isn't just stunning to look at, it's incredibly functional. Iceland sits directly on the mid-Atlantic ridge. So how do they harness this? And this brilliantly illustrates the process. Step 1. Deep underground, two massive tectonic plates are actually slowly moving apart. Step 2. This geological movement allows magma to rise and heat up these massive reservoirs of underground water. And Step 3. Ingenious engineers harness this high-pressure steam, running it through giant turbines to generate continuous, 24 hours a day power. It's essentially an unstoppable natural engine.
When you really break it down, by combining this incredible geothermal energy with hydroelectric power from their rivers and waterfalls, Iceland generates almost all of its electricity entirely from renewable sources. Think about what that means for an AI company for a second. They get massive amounts of clean, stable electricity, resulting in one of the absolutely lowest carbon footprints anywhere in the world.
We are talking about gigawatts of power. To put that into perspective, a gigawatt is the kind of massive energy you usually need to power an entire medium-sized city. So for an industry that is incredibly thirsty, consuming gigawatts of power globally, Iceland's ability to provide 24-hour clean, green energy at this massive scale, it's an absolute game changer.
Let's move to Section 3, nature's cooling system.
Because generating all that power is really only half the battle. The other half is getting rid of the intense heat that all that power creates. AI chips generate tremendous heat. When you pack thousands of these high-performance GPUs into a single building, the temperature just skyrockets. In a lot of countries around the world, data centers are literally forced to spend vast fortunes, huge amounts of energy and money, running massive air conditioning systems just to keep their servers from completely melting down.
But Iceland totally flips this script. Instead of energy-intensive server cooling, Iceland offers natural air cooling. Because it has a naturally cold climate pretty much year-round, data centers can just open up their cooling intakes and use the freezing outside air to cool their servers entirely for free. So instead of fighting nature with super expensive air conditioners, they're actually using nature as their cooling system. This dramatically reduces electricity costs and massively boosts efficiency.
Now for Section 4, security and connectivity.
Of course, keeping the lights on in the server school is fantastic, but tech giants also demand rock-solid infrastructure. And what's really interesting here is that Iceland checks a surprisingly diverse set of operational boxes that go way beyond just its climate and cheap energy. First up, data sovereignty. Because Iceland is inside the European Economic Area, companies benefit from much stronger data protection laws and digital sovereignty. Second, networking speed. Deep under the Atlantic Ocean, high-speed fiber optic cables connect Iceland directly to Europe with incredibly low latency. I mean, the data moves basically instantly. And hey, what about those volcanoes we mentioned earlier? Well, even those volcanic risks are carefully managed using highly advanced monitoring systems and protective engineering, which ensures these critical next-gen GPU facilities keep running safely and smoothly.
Finally, Section 5, the physical AI future.
You know, we tend to think of artificial intelligence as something totally virtual, like a ghost in the machine. But this explainer really highlights the elemental, physical reality behind that digital curtain. I absolutely love this quote. The future of artificial intelligence isn't just about smarter algorithms. It's about where those algorithms live. It's a beautiful, almost poetic contrast when you really think about it. The raging volcanoes deep underground provide the heat, the freezing glaciers in cold climate provide the cooling, and together, these primal forces of nature create the renewable energy that powers the thousands of GPUs making up this newly transformed global infrastructure hub.
It is literally powered by a volcano. So I want you to remember this the next time you pull out your phone to use ChatGPT, or the next time you type a prompt to generate a piece of digital art, or even just as you watch AI continue to transform our entire world. A significant part of that incredible futuristic intelligence was very likely powered by ancient Icelandic geology. Crazy, right?
It completely changes how you view the physical footprint of the internet. With the massive demands of AI forcing tech giants to look for these unique, natural advantages, it opens up a really fascinating discussion about the future map of global technology. So, I'm going to leave you with this question to ponder. Based on the insane energy and cooling needs of this industry, which country do you think will become the next AI superpower? Think about it.